Hi guys. Let's see. Yeah, you can read that. Parallel, perpendicular, or skew. And I give you two equations of lines. So they're two different lines. So they could be parallel, they could be perpendicular, or they could be skew where they miss each other. So let's see what we got here. And we're looking at these direction vectors. Let's do 3, -1, 2 dotted with 2, 4, -1 because the dot product detects perpendicular. So this gives me 6 minus 4 minus 2, which equals 0. So maybe perpendicular. What do we have to check? We have to make sure these lines intersect because they could be perpendicular but missing each other. So we got to find out if these lines intersect. Well, there's a fast way to do that, believe it or not. And it goes like this. I'm going to erase this part. Oh, and by the way, you're going to get a copy of all these questions well, you already have it because I'm going to send it out with the email announcement of this video. So you don't have to write anything down. You can just watch. Now, if these two lines intersect, that means that there is a place where this line has the same point as this line. So it means they have the same x-coordinate. So here's the tricky part. They don't have to meet at the same t. This is a crucial idea. So I'm changing this to just another letter of the alphabet. Let's call it S. And what we do is we say, okay, let's have the x-coordinate be the same. 3t plus 1 has to equal 2s plus 3. Well, that's one equation with two unknowns, so there's no solution of just that. So let's take the second coordinate. The second coordinate says -t plus 7 has to be equal to 4s plus 11. Now we've got two equations with two unknowns. That's solvable. We can solve this system. I would multiply through by 3 and just add straight down because that'll cancel the t's. So this is going to be 3t minus 3t, 0. 1 plus 21 is 22. 2s plus 12s is 14s. And then I have 3 plus 33 is 36. All right, so this is 14s equals, and if you do 22 minus 36, you get -14, a very good sign. S equals -1. So that means that when S equals -1, there's a place where these, at least the x and y coordinates are the same. We didn't check the z coordinates yet. When S equals -1, let's find out what t is using this guy right here. Okay, so S is -1. 2 times -1 plus 3 is 1. Oh, that's t equals 0. 3t plus 1, this is t equals 0 over here. So we have S equals -1, t equals 0. But that's just for the x and y coordinates to match. So the acid test is, do the z coordinates match? And notice we have one more coordinate completely unused. We haven't used the z coordinate at all. So if this pair of choices gives us the same x and y and z, then these two lines intersect. So for the z coordinate, 2 times 0 plus 2, we wonder if it equals -1 times, s is itself -1, plus 1. So we have 2 equals 1 plus 1, check. So the answer is they are perpendicular. The lines meet and meet at right angles. And I actually, if I want to, I can say what the point is. All I have to do is substitute in t equals 0, which means the point is 172. So they meet at 172. If you substitute in -1 for s, you can check and see. You're going to get 3 take away 2, that's 1. And then 11 take away 4 is 7. And then 1 take away -1, which is adding 1, I get the 2. All right, now if you were here, you could ask me all these questions, but you're not here. So let's take a look at the next question. So if you've got your computer on and you're watching this the way I expect you to be, you've got the ability to look at the PDF. So you already know what the next question is. Maybe you even tried it on your own. So the next question says, do we have parallel or intersecting planes. And that is 3x plus 2y minus 4z equals 3. And the other plane is 6x plus 4y minus 4z equals 6. So for a second there, when we're looking at these two equations together, I see the 3x and the 6x, that's times 2. The 2y and the 4y, that's times 2. But then the minus 4z's stay the same. So there's no way they're parallel. So the normals are not multiples. So that implies the planes are not parallel. Well, we only have 3 dimensions, so if you got 2 planes, they must be intersecting. All right, well, let's find those the place where they intersect, because that's in the instructions. I would do the following. I would try and find a way to substitute one equation into the other, and the fastest one I can see is, well, actually, let's take advantage of that multiple x and y stuff. I'm going to rewrite this thing times -2, and I'm going to write it down here. So I get -6x. I'm going to take -4y. I'm going to have positive 8z. And I'm going to have -6. And an interesting thing happens. X's cancel, Y's cancel, and I get 4z equals 0. That means z equals 0. So I'm supposed to find a line where these two planes intersect, and that line has z coordinate fixed at 0. That's big news. So my line, well, here's the answer. My line, I still don't know the direction vector, but the z coordinate is fixed at 0. So the z coordinate is fixed at 0. So my z coordinate stays 0 all of its life, which means that when I throw t in there, that has to be 0 as well. Because if that z coordinate times the t has any number in that spot, I get a non-zero z coordinate. So I found out 2 things already. Oh, and you're thinking, well, what if you have a 1 here, make that -1? No, but that only works for t equals 1. Not good enough. You need z to be stuck at 0, which you can kind of suspect when you look at the 2 original equations, that the x's and the y's are kind of in proportion, but the z's stayed the same. So set z equals 0 means that, so for the rest of this line, if z equals 0, check it out. If z equals 0, that's 0 for that plane, and that's 0 for that plane. And you see, it's the same equation. Same. All right, so that's the relationship between x and y. So let t be x. If t is x, then you have 3t plus 2y equals 3. So y is equal to 3 minus 3t divided by 2. So this gives me my line. I got a -3/2 right here. And I've got a 1 because I let x equal t. I got a 1 right there. Now I just need coordinates for the rest of the point. I need an anchor point. Okay, so where are we going to get an anchor point from? We need a place where these 2 lines intersect, or sorry, the 2 planes intersect. And we already know that we have these things. We have the x equals t. Oh, and but look, the y is 3/2. So I've got a 3/2 there. So I'm going to put that, we can write it here. And the x is just t, so I'll stick a 0 there. And that should work. That should give me something. Now let's see if that's the right stuff. Let's just check. Let's say we're paranoid. Is this the line? Now if that's the case, then we choose a value for t and verify that it makes both plane equations true. So I'll choose I'm going to choose t equals 4 to cancel out that 2. and I get the point. 4 times 1 is 4. 4 times negative 3/2 is negative 6. Plus 0, plus 3, whoops, plus 3/2 there. And I have a 0. So I still got the 3/2. That was really not smart of me. I should use t equals 1. That would have been smart. The 3/2 would have bought it. But anything should work. So I'm going to have the 4, and this is 12/2 minus 3/2. 12/2 minus 3/2 is negative 9/2, 0. Now, that should be in both planes. So let's try it. So my one plane was 3x plus 2y. I like that 2 times the halves. That's a good sign. Minus 4 times 0. And that's supposed to equal to 3. Let's see what we got. I got 12 minus 9 equals 3. Check. The other plane has, now if you think about it, it should still work because the other plane has a 6 and a 4 and a 6 here. So it's like doing this calculation over again, multiplying both sides by 2. So you guys should check the details of what I just said. That's really all I have to do. This point is in both planes, and I made it out of thin air from that line. So I'm pretty sure that we did okay. So the line is 1, negative 3/2, 0t plus 0, 3/2, 0. And then the other thing logically equivalent to that answers that one. All right. So intersecting planes, you got to come up with, you got to turn your two equations of planes into a line. So it's going to be substitution. You got to eliminate a variable and then eliminate, then use whatever relationship between the two remaining variable is to define part of your line, and then you get the rest of it from working like we did. All right, so we found the line of intersection between the two planes and checked. Let's get a vector perpendicular to the vector 1, 4, negative 2. I've got another coordinate on there. Hang on a second. I gotta call up my page. 1, 4, negative 2, negative 5. Okay, 1, 4, negative 2, negative 5. So anything that dots with, it just has to be non-zero. So anything that dots with this and gives 0. So I'm thinking, 1 plus 4 is 5, so that'll work because that's 4 plus 1 minus 5. So that's an example. Let's do another one real quick. How about if I do 2, 2, so that's 2 plus 8, multiplying here. That's 10. This 5 can kill off the whole thing. But let's use the 2 to kill it off. How about negative 5 there, or positive 5 there? Positive 5, 0. That'll work. So these vectors, each of these is perpendicular to that vector. So you just make stuff up. It's okay. And were we supposed to get something parallel to it as well? All you have to do is multiply by any constant, and that's a vector parallel to the given vector. All right, so let's get the equation of the plane through the points. 3, 4, 7, comma, 1, negative 1, 0, 2, 0, 2. Now this is one of those things where you should be doing your little IQ test. You're looking at this thing and saying, I think I see a pattern. It's not too tough to spot, but pretend you don't see it. Well, let's get a direction vector. 3 minus 1 is 2. 4 minus negative 1 is 5. 7 minus 0 is 7. Let's get another direction vector. 1 minus 2 is negative 1. Negative 1 minus 0 is negative 1. 0 minus 2 is negative 2. You might as well just do this. I'm going to save myself 3 minus signs because this is the same direction, just turned around. So there's my 2 direction vectors. No minus signs. That's nice. Then I'm going to get the normal. Okay, I see a 10 minus 7, that's a 3. I see a 4 minus 7. That would be negative 3, but it's a j. I'm giving it a positive 3. Now I see a 2 minus 5. 2 minus 5 is negative 3. So my normal, I can use a normal like this. 1, 1, negative 1. That's a really nice normal. Ones are great for calculations. So I'm going to erase that. Give myself some space. Those are my ABC for the equation of the plane. So I have x plus y minus z equals big D. And I can put in any point. So when I put in 3 plus 4 minus 7, that equals 0. I'm going to double check with 1 minus 1 equals 0. Yep. And that means, of course, this is the equation to the plane. And you might have seen it right away as the z coordinate is the sum of x and y. Now, if you saw this, z equals the sum of x plus y from the 3 points, you got the right answer, because there's only one plane that satisfies, or that all 3 of these points satisfies, because 3 points determine a plane. So there's only one plane that fits these 3 points, and you've got it. There is no other answer. So you can go the long way, or because you're a genius, save yourself a lot of work. And this is allowed. I want you guys to be smart. I want you to have the opportunity to finish a problem in under a minute because you're a genius, rather than, oh, you got to do what the teacher says to do. You got to do what the book says to do. No, no, no. You're past that now. You get to think like crazy. All right, I think there's a couple of surface problems to do, and I got to get them on my screen here. Hang on a second. All right. I got a z equals 1 minus x squared, and then a sphere. Okay. Z equals 1 minus x squared. So this is a cylinder, and it goes along the y-axis because the letter y is missing. So I'm going to try this thing, see if I can get it in one shot. Z equals 1 minus x squared. So when x is 0, z is 1. When x is 1 or negative 1, z is 0. So I've got a parabola coming down like this, and it continues to come down. So all I got to do is draw another shape like that one over here and draw this. Now this is happening in the background. And here's the y-axis. It comes shooting out like that. What do you think, huh? It's a tunnel. It looks like a tunnel that cars would drive through, but it's parabolic shaped. And if you were to write a description, you'd say it's a cylinder along the y-axis. It has the cross-section of the downward-shaped parabola of z equals 1 minus x squared. You say something like that, I'm happy. It means that you see the picture. It's a terrible picture, but you still can kind of see what's going on. I mean, if you wanted to draw it without any axis stuff, now that you've really got it, it's perfectly cool to draw things twice. Done. There you go. Just draw the minimum amount to make it clear. Don't do, like I get the student, let's get some shading in here. Oh, you're going overboard now. It's fine, but there's no need. It doesn't really help any. All right, and then there's a sphere with center 1, 2, 3, radius 4. And that would be x minus 1 squared plus y minus 2 squared plus z minus 3 squared equals 16, because you have to have r squared. And that's the end of our video for today. I got it done in under 20 minutes. I wish you guys were here, joking around with me and stuff, but that's about right for the test. I mean, it takes me 20 minutes to do the test, and that means that even if you got lost, you still have, because they'll give you an hour, you'll have plenty of time. So when you have the test in class, either be ready to leave early, because if you finish in 20 minutes, you're as fast as I am. If you finish in 30 minutes, then you still get out a half an hour, because I'm not going to do any class No classwork after the test. So, because you know what it's like to sit and wait for everybody to be done. All right, you guys. That was a good video. I hope you liked it. Bye.